Question is the value of integration 1 minus cos 2x upon 1 plus cos 2x dx is. These are the four options given to us. See, in numerator and denominator, we are to remove this one and this one. We have the formula for cos 2x as this is equal to 2 cos square x minus 1. Another formula we have 1 minus 2 sin square x, and another formula is cos square x minus sin square x. Out of these formulae, if we are to apply them here, then we can simplify this expression. Now, suppose this integration is I. This is equal to I is equal to integration. Now, 1 here, if I use this formula here, 1 minus 2 sin square x, then 1 minus 1 and hence 1 will be cancelled and the expression will be simplified. So, I write 1 minus, applying this formula, 1 plus 2 sin square x upon, now here I should have minus 1 in the denominator. So I am to apply this formula so that 1 and 1 are cancelled. So 1 plus 2 cos square x dx minus 1 dx. Now 1 and 1 are cancelled. Here 1 cancels this one. This is equal to, now 2 and 2 are also cancelled. So it will be tan square x dx. This is equal to integration. Now we have the trigonometric formula that 1 plus tan square x is equal to sec square x. So tan square x can be written as sec square x minus 1. So I am writing tan square x as sec square x minus 1 dx. We have now reduced the expression in the form of standard formulae. We know that integration of sec square x dx is tan x. So this is equal to tan x minus integration of 1 dx we know is x. So minus x here plus c, constant of integration. The value here c is the correct answer, tan x minus x plus c. Question is the value of integral 1 upon under root 32 minus 2x square dx is. These are the four options given to us. In denominator, we observe that the expression below the radical sign has 2 common. So first we take 2 as common. So I becomes, the given integration I am writing 1 upon root 2. If I take 2 common, then root sign is already there. So 1 upon root 2, integral of 1 upon under root, here it will be 16 minus x square dx. Clearly, this is of the form 1 upon under root a square minus x square, which is the standard integration formula. We write this formula first. Integration of 1 upon under root a square minus x square dx is equal to sine inverse x upon a plus c. This is our standard formula. So bring this expression into this formulae form. So 1 upon under root 2 will be outside. It will be integration 1 upon under root. I can write this 4 square minus x square dx. That is, here a is equal to 4. So this becomes 1 upon under root 2 sine inverse x upon 4 plus c, where c is the constant of integration. So we find that option B here is the correct option. Integration log x dx is equal to. These are 4 options given to us. We should know that integration of log x can be found using the formula of integration by parts. First we see what is the formula for integration by parts. Integral of u v dx if u is the first function, v is the second function, then this is equal to u first function integral of v dx minus integration of differentiation of first, that is du by dx into integral of v dx this dx. This is the formula for integrating using integration by parts. Now here the second function we can take as equal to 1. So I will be equal to integral log x, second function we are taking 1 dx. This is equal to, use the formula, so it will be log x integral of 1 dx, I am writing directly as x, minus integral differentiation of first, and differentiation of log x we know is 1 upon x. So it will be 1 upon x, integral of the second, which is equal to x dx. This we obtain. X cancels this x. So I obtain integration of dx, which is equal to x. So I becomes log x into x minus x plus c, where c is the constant of integration. Now I can take x as common in both these functions. So it will be log x minus 1 in the bracket plus c. 1 I know can be written as log e to the base e. So this becomes x into log x in bracket log x minus log e plus c. Base I am not writing, and I know that log m minus log n is log m upon n. So using the rule of logarithm, I can write x into log of x upon e to the base e. Here I can write e also. If I am not writing, that is assumed as e. So this will be our final value of I. So here option C is the correct option. X log x upon e plus c. Question is, integral of dx upon x into x plus 1 is equal to. 4 options are given to us in this manner. See, we have to do first the partial fractions. Now we know that 1 upon x into x plus 1, this is of this form. So let us say this is equal to a upon x plus b upon x plus 1. Now we have to find the values of a and b. So 1 will be equal to a into x plus 1 plus b into x. Now if I put x equal to minus 1, this will be 0. This gives us 1 is equal to b into minus 1, which gives us b is equal to minus 1. And if I put x is equal to 0, then this will become 0. So here I obtain 1 is equal to a into 1, because I have put x as 0. This gives us a equal to 1. Values of a and b I have obtained. So the given expression can be written here. This expression can be written as 1 upon x minus 1 upon x plus 1. I have done the partial fractions. So the given integration, I becomes integral of 1 upon x minus 1 upon x plus 1 dx. We know that integration of 1 upon x dx is log x. Log mod x, I am writing log x minus integration of 1 upon x plus 1 can be written as log modulus x plus 1. I am writing log x plus 1 plus c, which is the constant of integration. Now I have obtained the form log m minus log n, which is equal to log m upon n, using the properties of log. So I can write this as log of x upon x plus 1 plus c, the constant of integration. This is the value of I. So here option A is the correct option.